I'm Cassi, and we're going to be doing section 3.1 out of the book, strategies for solving equations.
And by the end of this lesson, students should know how to solve equations in multiple.
First vocab word for this section is variable, which is a symbol used to represent one or more numbers, such as x and y. And then these are all the words that we're going to be using in the lesson. The first one is rewriting, and that's writing an equation in a different way that's easier to solve. And the second one is graphing, which is a spatial representation of equations or numbers. And then undoing is using the inverse operations to solve a problem. And looking inside is making a logical guess to solve a problem with parentheses or absolute value. So for this problem, for part A, they're asking us to rewrite this equation so it's going to be easier for us to solve. So we're going to do that by multiplying each side by 2. That's going to get rid of these decimals. So it's going to end up being 2x squared plus 5x minus 3 equals 0. So that's our new equation. And in part B, they're asking for us to solve. So we're going to write that again. And from there we can factor it into 2x minus 1 and x plus 3. And then we're going to set these both to 0. So we can solve. So this is going to be 2x equals minus 1 plus, cutting this part out. And so that's going to equal 1/2. So that's one of our answers. And then this one is just going to be equal to minus 3. So we're going to bring this.
Now we're going to do example problem number 5. And A is a good one for doing looking inside. And it's probably the only one we'll do for this. So first we'll simplify it and we'll divide by 4. So then it's absolute value of 8x minus 2 equals 2. And then we can pull out another 2 and have 4x minus 1 equals 2. That would simplify to 4x minus 1 equals 1. And this is the part where we look inside. And so you can either do it in your head or you can write it out, the equation. So everything in this has to be equal to either 1 or negative 1 because it's absolute value. And that's easy to solve. We do 4x equals 2 and then x equals 1/2. And then the other part is 4x minus 1 equals negative 1. So then 4x would have to equal 0, so x is just 0. So those are our two answers for looking inside. And then for B, this is one that we're going to do undoing, which is a pretty simple strategy. And first we're going to subtract 9 from each side. So then on this side we have 6. And then we're going to divide by 3, so then we have radical 4x minus 8 equals 2. And then to get rid of the radical, we just square it, because when you're undoing, you always do the inverse operation to simplify. So then you have 4x minus 8 equals 4. You add 8 to each side, and you have 4x equals 12, and then just divide by 4, and you have x equals 3. Okay. And then for part C, this one is a rewriting one. And for rewriting, you just write it in a way that's easier to solve. So first we're going to FOIL this and combine both sides. So it's 2y squared minus 7y plus 6 equals negative 12y plus 18. And then we'll try to get everything on one side. So then 2x squared plus 5y minus 12 equals 0. And then we're going to factor that into 2y minus 3 times y plus 4 equals 0. And then we can use the 0 property to set each of these equal to 0. So then it's 2y minus 3 equals 0, and 2y equals 3, y equals 3/2. And then the other part, y plus 4 equals 0, y would just be equal to negative 4. So that's an example of rewriting. And then for part D, this is kind of rewriting and undoing. We're going to do a little bit of both. First, we're going to find a common denominator for the fractions so they're easier to add and subtract. So we're going to have the denominator be 3x. So that'll make it 15 over 3x plus 1 over 3x equals 4x squared over 3x. And once we get to that point, we're going to multiply everything by 3x to get rid of the fractions. So then it'll be 15 plus 1 equals 4x squared. So then 16 equals 4x squared, and once we get to that point, we're just doing kind of undoing. So we'll divide by 4. So then 4 equals, so we're going to write this as two equations here. 3 minus 7x equals negative 6, or 3 minus 7x equals 6. And for this one, we solve a negative 7x equals negative 9. So then x is 9 sevenths. And on this one, it's negative 7x equals 3, and x is negative 3. Okay, so that was a pretty simple one. And then for f, this one is rewriting. And kind of like the one before, you have to get a common denominator. So we're going to write this as 18w minus 3 over 15 minus 3w equals 12w minus 16 over 15, because 15 is our common denominator. And then we're going to multiply both sides by 15 to get rid of the fraction like we did before. So then 18w minus 3 minus 45w equals 12w minus 16. Okay, so then we'll just combine like terms, and we end up with negative 27w minus 3 equals 12w minus 16. And then we add 16 to each side, so then it's negative 27w plus 13 equals 12w. And once we get there, we'll add 27w to both sides. So then 13 equals 39w, and we divide by 39, so w equals 13 over 39, which can be simplified to 1/3. And that is our answer. Okay. Then G, this is an easy one. It's undoing. You just add 2 to each side. And you have x minus 3 squared equals negative 3, and then you radical each side, so then it's negative 3 equals radical negative 3, and x equals radical negative 3 plus 3, which would then simplify to I radical 3 plus or minus I radical 3 plus 3, and that is our answer. Okay, and then the last one that we'll do for this problem is a rewriting one. First, we're going to get rid of all the parentheses. So then we have x squared plus 4x plus 4 plus 4x plus 8 minus 5 equals 0. Then we can combine like terms, and we will have x squared plus 8x plus 7 equals 0. And then what I did was I just factored this back into parentheses, and we get x plus 1 times x plus 7, and you just use the 0 property, set each equal to 0, and your answers are negative 1 and negative 7.
So for this equation, we're going to solve it by 2 ways. We're going to solve it graphing and undoing. And to graph this equation, since it has to be 2 variables when you graph, we have to split it up into 2 parts. So the first part is going to be x minus 2 squared minus 3. And the second part is going to be y equals 1. And so here's the graph, and where these 2 lines meet, that's where our solutions are going to be. So we're going to solve this by undoing. So we're going to add 3 to both sides. We're just going to make it x minus 2 squared equals 4. And then we're square rooting each side. So it's going to be x minus 2 equals plus or minus 2 because we have that square root. And so there's going to be two answers. So it's if it's plus 2, plus minus 2, we're just going to add 2 to each side, and x is going to equal 4. And then if it's minus 2, we're going to add 2 to each side, and x is going to equal
Problem number 11, and part A that we'll start with is an undoing problem. So first we're going to subtract 7 from each side, and we have 2 times x minus 1 squared equals 32, and then we'll divide by 2, so we have x minus 1 squared equals 16, and then we will take the square root of each side, so then it's x minus 1 equals plus or minus square root of 16, which is plus or minus 4, and then we'll add 1 to each side so that x equals plus or minus 4 plus 1. So then the solutions are 4 plus 1 equals 5, or negative 4 plus 1 equals negative 3. Okay. And then the next part, B, is also an undoing one. And we'll start by dividing each side by 7 so that we have radical m plus 1 minus 3 equals 3. And then we'll add 3 to each side. So we have radical m plus 1 equals 6. And then we'll get rid of the radical by squaring each side. So we have m plus 1 equals 36, and we'll subtract 1 from each side, so m is 35. Okay. Part C is a rewriting one, and we need to get a common denominator, so we'll use 6 because they all go into 6. So that means that we have 3x over 6 and 2x over 6 equals 5x plus 2 over 6. And like before, we will multiply by 6 to get rid of the fractions. So then it's 3x plus 2x equals 5x plus 2. And that makes 5x equals 5x plus 2. And the only way to get the x's on the same side is to do 0 equals, and then the 5x's would cancel each other out, 0 equals 2. And that's not possible, so that means that this equation has no solution. Okay, and the last one for this problem is another undoing one. So we'll first add 7 to each side. So then we have 4x plus 2 over 2 equals 15. Then we're going to multiply by 2 to get rid of the fraction, and we have 4x plus 2 equals 30. Subtract 2 from each side. 4x equals 28, and then lastly we divide by 4 and we have x equals 7. The last problem we'll go over is number 17, and all the parts of this question are rewriting ones. So the first one, it's a pretty nasty fraction one. 3 times x squared minus 4 fifths over 8 plus x squared minus 4 fifths over 4 equals 2. So first I'm going to get a common denominator, and we'll use 8 because they both go into 8. So we'll keep this one the same. 3 times x squared minus 4 fifths over 8, and then this one we'll have to multiply the top by 2 to get the denominator. So then it'll be 2 times x squared minus 4 fifths over 8, all equals 2. And then we can just add these, so then 5 times x squared minus 4 fifths over 8 equals 2. Then we'll multiply both sides by 8, so we have 5 times x squared minus 4 fifths equals 16. We'll divide by 5, so that x squared minus 4 fifths equals 16 fifths. Then we add 4 fifths to each side, so that x squared equals 20 fifths, which would simplify to 4. So then x squared equals 4, and x equals radical 4, which is plus or minus 2. And then the next part, it's kind of a similar one, but since 1 over n plus 1 appears in both parts of the problem and they're the same, for now we're going to substitute each part with u so that it's easier to solve, and then at the end we'll bring this part back in. So we have u squared plus 6u equals 27. And once we get there, we'll move it all to one side. So u squared plus 6u minus 27 equals 0. And I just factored this into parentheses. And I got u minus 3 times u plus 9 equals 0. So then we know that u equals 3 or negative 9 from the 0 property. And then once we have that part, we can substitute u back. So we'll do 3 equals 1 over n plus 1 for one of the equations, and negative 9 equals 1 over n plus 1 for the other. So for this one, we'll multiply by n plus 1, so then 3n plus 3 equals 1, and then we'll subtract negative 3, so 3n equals negative 2, and then we'll divide by 3 on each side, so n equals negative 2/3. And then for the other part, we'll do the same thing where we multiply by n plus 1, so then negative 9n minus 9 equals 1. We'll add 9 to each side. Negative 9, we have negative 9n equals 10, so we'll divide by negative 9, and we have n equals negative 10 over 9. So those are our two answers for part B. And then part C, we're going to do the same thing where we substitute this x plus 2 over 6 for u and solve that part first. So then we have 6u squared plus 7u minus 3 equals 0. And here I just factored it, so I did 2u plus 3 times 3u minus 1 equals 0. And then we can set these equal to 0 to get what u is. So 2u plus 3 equals 0. So then 2u equals negative 3 and u equals negative 3 halves. And then 3u minus 1 equals 0. So 3u equals 1 and u equals 1/3. So those are the two answers for u. And then we'll plug that into x plus 2 over 6. So x plus 2 over 6 equals negative 3 over 2. And once we do that, we'll multiply by 6. So x plus 2 equals negative 18 halves, which is the same as negative 9. So x plus 2 equals so then we'll go over to this side, and u equals 1/3. So then x plus 2 over 6 equals 1/3. We'll multiply each side by 6, and we have x plus 2 equals 6/3, which is 2. X plus 2 equals 2. Subtract 2 from each side, and you have x equals 0. So those are our two answers, and that's the end of our problem.
Say goodbye to the city. I think it's time to get away. I just can't shake